So there are graphs everywhere. I just want to ask how many of you have been in this situation where this is what's happening in your life. You get a project, and for the first 2 days you work, see work done, I'm going to kill it, and I'm going to get a whole bunch of work done. After about the second day, that pretty quickly goes down to nothing. And then you wait, time before the project deadline, it's coming. Then the day before, woo, all the way up here. Cram it in the night before. Instead of just kind of bringing this up to a smooth bit, doing a little bit all the time, and then bringing it down at the end. This is what we're going to be doing. We're going to be analyzing graphs. So here we have two graphs that don't say anything, and they really could be two different things. So now if I add a description on the x and the y axis, I'm now talking about a check account balance over time. There are 5 sections of this graph. So in section 1, my balance is saying steady. In section 2, I get a paycheck. And thinking about it, this probably should be in days, shouldn't it, instead of months. So I'm going to change this to days. In 3, the day I get paid, I go out and I very steadily spend more than I got paid, and my balance goes below what it was. Then in 4, I get another paycheck. And in 5, my balance is steady again, so I had decided not to go spend it all at Nordstrom's. But I could take that same graph and I could change my x and my y axis to be the level of juice in my cup and time over seconds. There's still 5 seconds of the graph, but I would describe it differently. So I have juice in my cup. Then in section 2, someone pours me more. In section 3, I drink it down. Section 4, someone puts an ice cube in it, and the level goes up. In section 5, it sits, yeah, I can't spell. It sits on a table. No one drinks it. So, graphs can tell different stories, and that's what we're looking at now. Now let's talk at the math of analyzing graphs, so then we'll be able to put them together. So, the viewing rectangle. So we're looking at this graph. In the next 2 screens, we're going to be looking at this graph, and we're just going to be answering a whole bunch of questions, and you'll see how much we can learn from a graph. So the viewing rectangle is just what is the rectangle that my graphing calculator must be on to see this. And you can see I go from -8 to 6. So x min is -8, x max is 6. Y min is -10, y max is 8. So I'm going to write those in there. It's going to be kind of messy. So x min is -8, x max is 6, y min is -10, y max is 8. This XSCL stands for X scale and Y scale, and that just means, am I counting by 1s, or am I counting by 2s, or am I counting by 5s? And on both cases, I'm counting by 1s. Okay, x-intercepts. So x-intercepts are ordered pair, and you can see that I have 3 here. I have 1, 2, 3. So I'm going to write them as ordered pairs. I have -6, 0. I have -2, 0. And I have 4, 0. And by the way, you should be doing this on the Analyzing Graphs worksheet that you picked up in class today. Okay, we have one y-intercept, which is down here at 0, -8. And is it a function? Will it pass the vertical line test? Yes, it passes the vertical line test, so yes, this is a function. What's the domain? So let's look at the domain. And, whoa, what is that? Sorry. So the domain is the left to the right, and we're going to use interval notation. So my domain is the left of the graph to the right of the graph, to the right of the graph. So my domain goes from -7 to 5, and the 5 is a closed circle, so it's a bracket, and the -7 is an open circle, so it's a parenthesis. My range, let's do the same thing. My range goes from bottom of the graph to top of the graph. Now be careful, the top of the graph is up here. I think some people would mistake the top of the graph for this section right here, okay? But the very top of the graph is way up here by 7. Okay, so bottom of the graph would be -9. Top of the graph would be 7. At -9 there's a point, so I have a hard bracket, and at 7 there's a closed circle, so I have a hard bracket also. I'd like to skip down to number 10, and I know we've talked about this before, but remember number 10, f of 2. What does it equal? Remember that 2 is really saying the x. So I'm going to go over to the 2 on the x, and I'm going to bring my cursor to where the graph is. I'm coming down and I'm hitting the graph right there. So f of 2 gives me -8. So when it looks like this, it's giving me the x. It wants me to tell that this is -8. So f of 2 would be -8. Now find f of -5. So again, my x is -5. So I'm going to go to the x at -5, and I'm going to go until I hit the graph. Well, the graph isn't down here this time, the graph is up. So I'm going to go up here, and I hit this graph at 3. So f of -5 equals 3. Now let's go back to 7. Where does f of x equal 0? So now we're looking at something different. We're looking at f of x equals 0. So now it's telling me that the y is 0. So now, if this is the y, I'm looking for the x. So, let's see. Here is where y is 0, right? The equation of a line, y equals 0, is a horizontal line across 0. So this is the line y equals 0. And I can see that y equals 0 at -6, at -2, and at 4. Where is number 8? Where is my graph less than 0? Well, my graph is less than 0 underneath that line. All of this piece and all of this piece is less than 0. This piece and this piece would be greater than 0. This is going to be really important when you get to pre-cal. So underneath here is where my graph is less than 0. So there's a piece from here to here. And remember, I want to be less than 0, and the green line equals 0. So this first interval, and I'm going to do this in, let's find a different color that I haven't used yet. How about purple? Okay, so I'm going to put the answers up here in the graph. Okay, so you have enough room on your paper to go ahead and write these answers, but I want you to see them. So there are two sections of graph where f is less than 0. This section and this section. This section goes from -7 to -6. And I would say, so -7 to -6. -7 is an open parenthesis, and -6 is where it would equal 0, and I don't want it to equal 0, so I want to be below -6. I also have an interval where it's less than 0 from here to here. So that would be from -2 to 4. And I don't want to equal 0, so those would be open parentheses also. So now I want to look at this question, where is the function greater than or equal to 0? So now I'm going to include the points that are on the line y equals 0. Again, this is the line y equals 0. So I want to know where I'm greater than or equal to 0. And again, there are two intervals that are above that line. So this interval is from -6 to -2. And I would write that -6 to -2. But since I can be equal to 0, I'm going to put a bracket on them. And this interval is from 4 to 5. 4 to 5. So, and again, there's a closed circle there, and I can touch the green line here. So this would be, let's see if I can make that a little wider, 4 to 5. Okay? We've already done 10 and 11, so let's jump down real quickly and do number 12. How many times does the line y equals 2 intersect the graph? So how many times does the line y equals 2 intersect the graph? So let's look at the line y equals 2. It would be right here. It intersects the graph 1, 2, 3 times. Now let's see if we can remember from the previous screen, what does this stand for? Is this asking me to find the x, or is it asking me to find the y? It is saying that f of x equals 4. That's the same as the line y equals 4. So if I go up to 4, I would hit right there at the top at -4. I would also hit right here, which looks like it's about 4 3/4. So this would be -4 and 4 3/4. Where does f of x equal -5? Here's -5. This is the line y equals -5. And this line would touch the graph at -1 and 3. Find f of -1 minus f of 2. Now remember, if I put the -1 inside, I'm now saying this is x. So if x is -1, here's -1, my y is going to be 5. So this is saying find 5 minus f of 2. X is 2. I come down here, and that hits at -8. -5 minus -8, that will become a plus, so this would be 13. Find 3 times f of -1. Going to -1, I hit the graph at 5. So I'm going to do 3 times 5, which would be 15. I'm going to run through the next problems just really quickly. I have an absolute maximum and I have a relative maximum. So an absolute maximum is the absolute top of my graph. There it is right there. I have a relative maximum. That's a relative maximum. It is the height of a curve. It is where I change from increasing to decreasing, but it's not the absolute top. Same with minimums. I have an absolute bottom of this particular graph, and I have a relative bottom. Okay? This information you won't need to know for the next test. I just want you to hear what it is. Where is the graph increasing? Well, it's anywhere the graph is going up. So I'm increasing right here. But as soon as I hit the top, I start decreasing. As soon as I hit the bottom, I start increasing again. So I would be increasing here, and I would be decreasing here. Okay, and one more slide. So you've now listened to a video for 15 minutes, and so I thought I'd share this with you. This is a report. This little boy's doing a report on Mrs. Irwin, and he says that Mrs. Irwin is a math teacher, and then he asks how old I am. Well, Trooper, in 5 years I will be 4 times as old as you were last year, and 3 times as old as you will be in 6 years. He changes his title from Mrs. Irwin is a math teacher to Mrs. Irwin is a jerk. I know you're mad that this was 16 minutes long. I apologize, but this is important stuff. Talk to you later.